So I'm Dr. Chris Arndt. I'm a professor in the mathematics department, and I am teaching Calculus 3, Math 216. In order to get the groundwork and the foundation, the mathematical tools to be able to do this extension to Calc 3, to multivariable functions. And so that's really the brunt of the course. The first month or so we spend building this toolbox of tools that we can then use. And then we bring in the usual concepts of calculus, derivatives, limits, integration, all with these functions of multiple variables. The main objective of the course is to get to that multivariable calculus, but to also establish a strong foundation in mathematical thinking and be able to take the tools already developed in Calc 1 and 2 and extend them into Calc 3. So right now, we're covering topics that have to do with partial derivatives. So just like in calculus, we introduce derivatives, and then we build upon them, thinking about things like tangent line approximations, differentials, linearization, optimization, local extrema. Well, now that we've extended it to multivariable calculus and have functions of 2 or more variables, we're doing the exact same thing. We're going to take these partial derivatives and use them to build linearization approximations using a tangent plane now instead of a tangent line. And then differentials to approximate change in change in range, right? And so once you have that change in range, then you can approximate it using the tangent plane approximation in differentials.
All right, so we kind of know the context. The gradient vector acts a lot like a derivative, right? So what can it be used for? What is this information I say it contains that's perhaps surprising? So to understand this, we want to turn our attention to trying to maximize the directional derivative, okay? So let's just play this out, okay? So we have our function f that's differentiable, and u is a unit vector, and we know how to calculate that directional derivative. So the directional derivative in the direction of u of f is equal to, well, we saw the big shortcut was the gradient dotted with the unit vector.
So the primary thing I want students to take away is a maturity in mathematics. Learning to learn mathematics is one of the big takeaways of this course, because many students, for the first time when they get to Calc 3, it's a course that challenges them. Even when math may have come naturally for a while, this is one of the first places that kind of the rubber hits the road and they run into some difficulties. But the big takeaway of the course is being able to overcome those difficulties. Now certainly we use the context of multivariable calculus, that's the core concepts we're trying to learn here. But the mathematical thinking that's developed to deal with these concepts is definitely the major goal of the course.